which is that C is a very simple language like Forth, Bliss, and the others. And even more importantly, because C has been ported to so many CPU architectures, the first thing most CPU designers do is port C to that CPU architecture, often via GCC. Although I suppose Clang LLVM is now a good alternative. In fact, C is so pervasive that it has a great deal of influence on the design of the CPU instruction set itself. C as a language doesn't really need a runtime environment. If you throw away standard libraries, unless your CPU is missing things like multiplication and division, stack operations, etc., floating point math isn't really necessary for most OSes, and if it's missing in the CPU instruction set, but needed by the OS design, then that's a bit of runtime support needed. C doesn't need support for heap memory management. You can provide your own heap memory management with something as simple as an enormous, fixed-size array. C++ needs heap management as part of the runtime support. And let's not get into what it means for a constructor for a static instance of a class at the OS level. That's not exactly true, as other languages are used to implement operating systems. BMS was implemented primarily in Bliss. BIOS had a fair amount of C++ in it. Windows has a fair amount of C++. I think there are Lisp-based systems such as Symbolics. Genera Multics was implemented in PL1. It is fair to say that languages other than C are not very widely used. There are decent reasons for this. C is a fairly portable language with aspects of high-level abstractions, but also with low-level abstractions, the latter being fairly critical. It is fairly easy to integrate bits of assembly code with C, which is useful for some of the low-level integrating with hardware parts of implementing an operating system. It is fairly easy to arrive at a C subset, often with the notable feature of eschewing the use of floating-point data types that requires little to no runtime support from outside libraries. With C++, in contrast, you need to avoid a lot more language features. Contrast with popular scripting languages, where you are likely to need a garbage collector as a separate runtime component to do memory management. That's not much good when one of the goals was to implement memory management. The model for linking together C function libraries has become very popular to the point that most scripting languages expressly allow extension via linking to C libraries. The equivalent for C++ is much more nearly C++-centric. C has been ported to run on a large number of hardware platforms, which means that there are a lot of people out there who know how to do this. The same is not so true for other languages. Note that with Bliss and Genera, the authors only ever had a couple of hardware architectures to worry about supporting. The PL1 implementation used for Multics was pretty tied to a small set of kinds of Honeywell systems. There are operating systems not implemented in C, but many are rather old, often predating C, and the complexity of implementing in other languages tends to be a formidable barrier. There are efforts ongoing on a Rust-based OS that seems pretty plausible,